Division by a monomial. Now remember, a monomial meaning one term. We're going to divide by a term. We're going to divide a polynomial by a monomial, where we're going to divide each individual term in the polynomial by the divisor. Your divisor is going to be that monomial. And then we're going to simplify the result. So first we're going to look at dividing by a monomial. Then the next set of videos we're going to look at dividing by a binomial and trinomial. So here's the definition. Let's say we have a fraction, a plus b over c. Well, we can write this one fraction as two separate fractions, where our divisor, which is c here, the variable c, would be the monomial. So we would write it as a over c plus b over c. And remember, we cannot have 0 in the denominator because it will make that fraction undefined. Next, parts of division. You have what's called a dividend. This would be number 1. And the dividend is the number being divided, or this expression that's being divided. Then you have what's called your divisor. That is a number that will divide the dividend exactly. Or that number, we can say it can be that monomial, that expression that will divide into the dividend exactly. And then number 3, we have here, this is the parts of division, our question, 12x squared plus 10 over 2, which equals to 6x squared plus 5. What is equal to is called the quotient. And the quotient is the result of a division. So here we're going to be looking at dividing by a a monomial. So let's start off with an example of what your question will look like. So example 1, we have here 9a to the 5th b squared plus 12a to the 4th b all over 3a to the 4th b. So what we're going to do is we're going to write this one fraction as two separate fractions because your polynomial, or we would say the dividend, is the binomial that's in the numerator. Our monomial, which is in the denominator, that is the 3a to the 4th b. So what we're going to do is write this expression out separately as two separate fractions. We have 9a to the 5th b squared all over 3a to the 4th b plus we have 12a to the 4th b all over 3a to the 4th b. So then what we're going to do next, we're going to simplify each fraction, meaning we're going to reduce each fraction. So let's look at our 9 over 3. Well, what can we divide out of 9 and 3? That will be 3. So 3 goes into 3 one time. 3 divides into 9 3 times. And remember the shortcut that I showed you in class, where whenever you have a quotient, meaning it's written as a fraction, and all of the powers are positive, and how we can reduce this without showing a whole bunch of work. So let's look at our base a. We have a to the 5th over a to the 4th. Where do you have the greatest amount of a's? In the numerator. So that's where we're going to place our answer. So we're going to subtract 4 a's from out of 5. We have an a. And then in our denominator, excuse me, our base b, our denominator we have a b, and then we in our numerator we have a b squared. We have the greatest amount of b's in the numerator, so that's where we're going to place our answer. So we're going to subtract a b from out of b squared, we have a b left. So this first term reduces to 3ab. Let's look at the next term. 12 over 3. Well, we can divide a 3 out of each. 3 divides into 3 once, 3 divides into 12 4 times. And then what's happening to our a to the fourths and our b's here? They're going to divide out. They're going to cancel out or meaning reduce to 1. And we have here 4. So our answer is 3ab plus 4. Now, depending on how many terms you have in the dividend, i.e. our numerator here, that determines how many terms you're going to have in your answer. So for this example, since we have 2 terms in the numerator, our answer, we must have 2 terms there. Now we can check our work. Checking our work is taking this 3ab plus 4 and times it to this monomial. And when we multiply that together by distributing, we're going to get the dividend that's listed here. Okay, let's do number 2. We have 4r to the 8th, p to the ninth, minus 4r to the 5th, p to the 7th, plus 10r cubed, p to the 4th, minus 6r to the 6th, p squared, all over 2r cubed, p. So we have 4 terms in the numerator, that's our dividend. So that means we're going to have, or we're going to write 4 separate fractions where we're dividing by this monomial. So here we go. Let's go ahead and write this out. And our last term here, writing this out. All right, so let's go ahead and reduce each term. So as we reduce each term, here we go. 4 divided by 2. 2 goes into 2 once, 2 goes into 4 twice. Let's look at our base r. We have r to the 8th over r cubed. We have the most r's in the numerator, so that's where we're going to place our answer. We're going to subtract 3 r's from out of 8. We have r to the 5th power. Our p's, we have the greatest amount of p's in the numerator, so we're going to subtract a p. From out of p to the ninth, we have p to the 8th. So our first term is 2r to the 5th, p to the 8th, minus, let's do the next term. Well, 2 divides into 4 twice. We're going to subtract 3 r's from out of 5. We have r squared. Then we're going to subtract a p from out of p to the 7th. We have p to the 6th. That second term is 2r squared, p to the 6th. Third term, 10 divided by 2. We can divide a 2 out of the numerator and denominator. 2 goes into 2 once, 2 goes into 10 5 times. Our r cubed, they're going to reduce to 1. They divide out. But our base p, where do you have the greatest amount of p's? In the numerator. So we're going to subtract a p from out of p to the 4th. We have p cubed. So that third term is plus 5p cubed. Okay, and then our last term, we have minus, and then 2 divides into 6 3 times. We have r to the 6 over r cubed. We're going to subtract 3 r's from out of 6. We have r cubed. And then our base p for the last term. We're going to subtract a p from out of p squared. We have a p. So then this gives us 3r cubed p. So this is our solution. 2r to the 5th, p to the 8th, minus 2r squared, p to the 6th, plus 5p cubed minus 3r cubed p. There we go.